You have probably seen artificial intelligence generate code, and the results can be pretty remarkable sometimes. But let us consider if this is maybe just the first step. What if there were a way to build software using methods that, well, our traditional tools just cannot handle?
That is a really interesting way to frame it because our sources definitely talk about a more advanced stage, moving past that basic AI code generation to something they call agentic coding, sometimes also referred to as AI agents.
Okay, so that is the core idea we are exploring today then.
Exactly. The main goal for us in this deep dive is to really unpack why this agentic coding is considered such a significant leap forward. Our discussion is based on analyzing materials like a YouTube video transcript and some related articles.
Right, and we want to clearly lay out the key differences between these two approaches for you. Our aim is to offer some perhaps surprising insights and a practical understanding without getting bogged down in, overly technical jargon.
Understanding this distinction really does seem crucial right now, especially if you want to, as the sources put it, win in the generative AI age.
Absolutely. So let us begin with the foundation. What exactly constitutes basic AI coding according to these sources?
Well, the information suggests basic AI coding is probably something you are already somewhat familiar with. It's essentially described as using a single tool call.
A single tool call, meaning one action or function.
That is right. Think of this tool like a simple function in programming. It takes some context, a specific model, and a prompt as its inputs. The main output from that single action is AI-generated code.
Okay, so you give it instructions, it processes them using its model and the context you provide, and out comes a piece of code.
Precisely. It is a fairly straightforward input-output process in that sense.
Our materials even mention ADER as an example here. Now, ADER is useful for showing principled AI coding, but it's characterized as having a specific limitation, right?
Yes, that is correct. The sources describe ADR as essentially a single tool with its functionality built right in. It does its one job well, but it is still fundamentally that single tool call mechanism.
And this limitation seems quite important based on the source material.
It does indeed. The sources state quite clearly that this kind of basic AI coding by itself is not enough for what they call real engineering work.
They use some strong metaphors to describe it, too.
They do, calling it just the beginning, like the tip of the iceberg, and even suggesting it's transitory. This really emphasizes that it's seen as just one part of a much larger picture.
Okay, so if basic AI coding is defined by this single tool, this one instance of code generation, what makes agentic coding the next level the sources talk about?
Agentic coding is presented as a really significant step up, described as a much larger superset of basic AI coding, meaning it includes that capability but goes much further.
And what is the key thing that makes it a superset?
The critical difference lies in its access to a much wider range of tools and functionalities. Instead of being limited to just that one code writing tool, agentic coding potentially has access to any tool you can think of.
Any tool you can think of. That certainly sounds like a massive difference in potential. The sources gave Claude Code as an example, didn't they?
They did. Apparently, Claude Code comes with 11 built-in tools, which is obviously a big jump from the single tool of basic AI coding.
Could you give us a few examples of those built-in tools? What can it do beyond just writing code?
Sure. The integrated tools include things like edit and write, which cover the basic AI coding functions we discussed. But then it adds tools like glob, grab, else, and read.
So tools that let it interact with the file system and understand the existing code.
Exactly. These tools are significant because they allow the agentic coding tool to actually analyze the entire code base. It can search for relevant information much like a human engineer would poke around to understand things first.
That makes a lot of sense for more complex engineering tasks, needing to understand the context before changing things. The sources also made a big deal about a bash tool. What is so special about that one?
The bash tool is highlighted as a major leap because it gives the AI the ability to interact directly with the operating system's command line, the terminal.
You mean it can run commands just like a developer would?
That is the idea. It can execute potentially any bash command. This effectively gives the AI a really powerful way to perform a huge range of system-level operations, and its capability here scales with how smart the underlying AI model is.
That opens up a vast range of possibilities, maybe for things like automated builds, tests, or deployments.
Absolutely. You could imagine it revolutionizing how automated testing or infrastructure management is done, allowing for much more dynamic and, well, intelligent interactions with the system.
That level of interaction is definitely beyond simple code generation. I also saw mention of a batch tool. What function does that serve?
The batch tool lets the agentic coding tool run multiple tools at the same time in parallel. This could obviously speed things up considerably for complex tasks that involve several steps.
And it had another capability, too, something about subagents.
Yes, and this is perhaps the more forward-looking aspect. The batch tool apparently also allows launching subagents. This hints at a future direction where these systems could become self-organizing, maybe even self-replicating, to tackle bigger and more complex problems autonomously.
This is starting to sound less like a tool and more like an autonomous partner in the development process.
Yeah.
The idea of programmable agentic coding was also stressed. What does it mean for these agentic capabilities to be programmable?
Programmable agentic coding, which tools like Claude Code exemplify, means that users can actually embed these powerful agentic abilities directly into their own existing tools, workflows, and projects.
So you're not just using a separate agentic tool, you are integrating its intelligence into how you already work.
That is the core idea, yes. This programmability allows you to weave this more advanced level of coding intelligence right into your current methods.
Our source material gave that simple Claude Code example, which looked incredibly straightforward compared to the Aider example, Aider message. Can you elaborate on why there's such a difference in complexity and power?
Right, that comparison between the Claude Code example and the Aider message example is quite revealing, even though both might aim to modify a file based on a prompt. It really highlights the fundamental difference in capability.
How so? What does the Claude Code example show?
The Claude Pick example shows you can specify allowed tools right there with the instruction, demonstrating the flexibility and the wide range of actions the agent could take. In contrast, the Aider example is focused on that specific file modification task, illustrating the more contained nature of basic AI coding.
And the point is that real engineering is rarely just one isolated action.
Exactly. The sources emphasize that engineering involves much more than just writing or changing a single file. It requires calling, as they put it, arbitrary tools in many, many, many different workflows.
The to-do list example drove this home quite well, I thought. Checking out a branch, creating a file, committing changes, all triggered by natural language.
Precisely. It is like giving high-level instructions to a very capable digital assistant that knows how to use all the necessary development tools.
That capability to orchestrate multiple tool calls using natural language seems like a core strength then.
It absolutely is a key advantage. And this connects to the idea of reusable workflows. Principled AI coding had a concept called ADWs, Agentic Development Workflows, which agentic coding tools like Claude Code seem to take much further with this arbitrary tool calling capability.
Allowing for more complex and flexible reusable sequences of actions.
Exactly, which improves efficiency and consistency across development tasks.
Things get even more interesting when we bring in custom tools via these MCP servers. How does that expand the potential even further?
MCP servers, or multi-capability provider servers, allow agentic coding tools like Claude Code to tap into a wider world of tools, both existing ones and completely new, custom-built ones.
So it's not just the built-in tools, it can connect to external capabilities.
Correct. The Notion integration example discussed in the sources is a perfect illustration. An MCP server acts as a bridge, providing access to the Notion API.
Okay, so the agent isn't just stuck in the code base anymore. It can reach out and interact with other applications like Notion. How does that actually work in practice?
Well, the workflow described involves the agentic tool first reading instructions from a Notion page. Then it analyzes those instructions. After that, it uses the Notion API tools provided by the MCP server like read, write, update, along with its own code editing tools to carry out the tasks.
And it can even update the Notion page itself, like checking off the task it completed.
Yes, remarkably, it can update the Notion page, perhaps ticking off items on a to-do list. This really shows the agent acting more like a human professional who switches between different applications and APIs to get their job done.
This paints a very clear picture of agentic coding being fundamentally different and significantly more powerful than just basic AI code generation. Could we maybe summarize the core principles that enable this?
Certainly. Agentic coding seems to rest on three essential ideas according to the sources. First, you need a smart model that's capable of figuring out which tools to call and when to call them.
So intelligent decision-making about tool use.
Correct. Second, you need the ability to call arbitrary tools, both the built-in ones and any custom tools made available through things like MCP servers.
That flexibility in tool access is key.
It is. And third, you need an agent architecture. This provides the necessary autonomy for the system to carry out complex, multi-step tasks without needing constant human guidance for every single action.
So it is not just about generating code anymore. It is a whole system that can reason, decide, act, and interact with lots of different tools to achieve broader engineering goals.
Precisely. If you think about the wider AI landscape, basic AI coding fits neatly into generative AI creating something, in this case code, based on a prompt. It is often a static output.
Whereas agentic coding is more aligned with agentic AI.
Exactly. Agentic coding represents applying agentic AI principles to engineering. Where generative AI is often static and focused on narrow tasks, agentic AI is dynamic, adaptive, and tackles broader, multi-step goals, taking actions autonomously.
This really does sound like a potential paradigm shift for software development. Looking ahead, what do the sources suggest about the future possibilities and implications of agentic coding?
The sources paint a pretty ambitious picture. They suggest agentic coding, with its ability to scale compute power and automate complex workflows, could be the end game, maybe even the future of engineering.
That is a bold claim. How might that future look?
Well, you could imagine scenarios with multiple agent instances working together on big projects. Maybe specialized reviewer agents could automatically check code changes. The sources imply the capabilities are really only limited by what we can design into these systems.
It connects to that idea of living software mentioned in the material.
It aligns perfectly, yes. This vision of autonomous software entities powered by agentic coding seems to be where things are headed.
And it seems there is already a lot of excitement building around this.
There is. The development of next-gen courses focusing specifically on these agentic coding tools is mentioned, even though some tools like Claude Code are still in what they call a research preview.
So we can expect to hear a lot more about this as these tools mature.
I think that is very likely. As these tools move beyond the research phase, we will probably see wider adoption and a deeper exploration of these agentic paradigms, which could fundamentally change how we build and maintain software.
Okay, so to quickly recap our deep dive for everyone listening, the really crucial distinction is this. Basic AI coding offers a single tool for generating code. Agentic coding, however, provides a whole framework for autonomous action, using many different tools to achieve complex engineering goals.
That is an excellent way to summarize the core difference. Understanding this shift is genuinely important for anyone wanting to stay current in the fast-moving worlds of AI and software development. Agentic coding really does seem to unlock a new level of potential impact and efficiency in engineering.
And now, a final thought for you, our listener, to reflect on. Thinking about your own work, what specific engineering tasks that currently take up a lot of your time and mental energy could potentially be automated or significantly sped up using these programmable agentic coding tools? What entirely new possibilities might this open up for your projects or even your career path? It is definitely something worth exploring further.